I remember that still back in the 90s, there were all kinds of jokes about the supposed poor quality of cars and other goods that had been made in East Germany during the decades of the Cold War. Out of a certain arrogance, I suppose, people in West Germany liked to make fun of the Trabi and its plastic body panels. In fact, that East German automaker had decided to make the body shell of their cars from Duroplast, a fiber-reinforced plastic made from recycled materials. The main reason for doing that was that the German Democratic Republic, as it was called, faced regular shortages of steel and had little to no iron ore reserves of its own. Yet many of the products that are sold in stores are so cheaply made that it would put the East Germans to shame. Like this chintzy bench grinder here that is almost entirely made of plastic. I can tell you one thing, East Germany faced shortages, but they still managed to build quality tools, like my milling machine here, and they exported them to many countries around the world. Since I've started to get more into metal casting, I have also started to melt down things on a regular basis. And this makes me think about the metal content of discarded items all the time now. It has made me realize even more than before that modern objects are often made from very cheap disposable materials. This scrapyard here still holds a few examples for tools and machines that were made using much more expensive materials and manufacturing techniques. So let's look out for that and see what we can learn while trying to bring them back to the world of the living. So let's see then what we can find here today. After walking around for a while, I peeked into this small container here where electric motors and everything with electric motors is collected for scrapping. And look what I found. A really old two-handed Fein brand power drill. With any luck, we can combine it with this broken Fein mag base that I got my hands on recently as well. But that same container had more to offer. Behind the drill I found this rather rare but really massive METABO brand saw, and we will take that home as well. And out of historic curiosity I also took this old hydraulic pump from that same container that we will have a brief look at as well. Not on that same day, but at the same place, I also stumbled over this rather odd grinder here that we are going to restore in this video as well. In fact, over recent weeks and months I stumbled over a whole number of rather run down and antique but also really robust power tools like this Rema brand polishing machine and this really kind of run down METABO bench grinder. So these finds here might not look like much at first glance, but they might as well turn out to be diamonds in the rough. So let's head over to the workshop and let's see if there will be a second spring for these relics of a bygone age. The first object that I'm going to take care of is this sander. The overall styling of the motor and the materials that were used make this device appear very old-timey. In fact, the motor and the mechanism connecting to it are made from cast iron parts. The end shield on the drive side of this induction motor displays the name of the manufacturer, Georgi Kobold. This company still exists. They are situated in the southwest of Germany and they are specialized in making electric motors. It doesn't seem like they make entire machines or power tools today. However, the seamless way in which the castings fit the motor leads me to believe that this was all made in-house. I also learned from a promotional video that they still make castings, even though that's more likely aluminium than cast iron these days. The gray, rather glossy looking top layer of paint is probably not original. I say that because of the rather sloppy way it was applied. We'll have a closer look at that in just a minute, but before that I wanted to have a closer look under the cover to identify what type of induction motor this is. So after removing the old power cable and unscrewing that cover, I can see that this is a three-phase induction motor currently wired in a delta configuration. The 6 electrical connections are the two ends of 3 windings, currently connected in a triangle, often referred to as delta in the English language. This is the same general setup that is still used on three-phase induction motors in Germany to this day. The delta configuration is often used to run these motors on single-phase AC when three-phase is not available. However, in order to run the motor this way, a motor capacitor needs to be added, and I see no sign of a capacitor being connected here before. Normally, I would give the former owner the benefit of the doubt and suggest that the capacitor was simply cut off by someone, but that doesn't seem to be the case here. And because it will be a running theme throughout this video, I have to make the following assumption. Many perfectly good devices, tools and machines are being thrown away and scrapped because many people don't know how to identify the basic types of electric motors, and they don't know how to wire them up. But more about that later in the video. So why not test it right here and right now? Well, I took some quick measurements and I'm quite sure that the motor itself is not broken electrically, but I still want to have a look inside before powering it up, because I follow the old adage of don't turn it on, take it apart. And because I suggested before that these finds might be diamonds in the rough, let's remove that rather hideous paint job and you'll see what I mean. Now, normally I would take the motor apart first and have a look inside before taking care of superficial things like the paint. In this case, however, I simply couldn't stand to look at this for another minute and acted somewhat irrationally. Because of the overall shape of the device and the type of paint used, I decided to use a chemical paint stripper. I've used this stuff on and off for a number of years now, and I have come to the conclusion that especially in warm weather, it is necessary to apply this gelatinous stripper to the surface with a brush and then quickly cover the surface in plastic wrap, or in this case with 1 or 2 layers of garbage bags. If you don't do that, the stripper will dry out very quickly, which makes it much harder to remove the paint, and you will also need way more of that rather expensive stuff to get it done. Depending on outside temperature, the thickness and type of the paint, etc., it will then take a few hours to a day until the paint will have turned into a wet, easily removable mush. After scraping and washing off most of the paint, I now decided to take everything apart and also clean the motor from the inside. It turns out that there was a lot of dirt, grime and dust inside. To take care of both that and surface rust, I suspended the end shields and the rotor, but not the stator, in a bath of citric acid. In addition to the paint stripper, a lot more work was needed to really get nice clean surfaces. See, there is just no ideal solution. While citric acid might remove rust and dirt, it is not strong enough to dissolve such thick coats of paint. The paint stripper can do that, but it also leaves behind a disgusting sludge and very strong smell that is hard to get rid of entirely. Sandblasting can be used, but with mechanisms and motors, there is always a chance that blasting media will be trapped in the bearings and other sensitive spots where they will cause problems later on. Last but not least, I wire wheeled all the parts to get a nice finish. I also applied some grease to the old bearings before putting everything back together. Later, I also decided to spray paint the sander in several layers of transparent varnish, because I prefer the beautiful look of raw cast iron over any type of paint. It's just a matter of taste, I guess. So with the paint dried, I also connected a motor capacitor to the device, and if I remember correctly, I tried different sizes between 5 and 10 microfarad. Generally speaking, I do not enjoy giving direct advice over the internet on how to do something like this. The reasons are manifold, and one reason is that the audience is from all over the world, and while there is a certain logic to identifying the wiring scheme of motors that were made here in Germany, the same rules don't necessarily apply to motors from other countries or other time periods. I will still try to give some guidance, as we will encounter different motor types throughout this video. I also did my best to cut out a circular piece of sanding paper of the same size as the old one that came with the machine. And now it was time for a test. I think the machine looks pretty good, but it needs a bigger, heavier base to be mounted on. And I want to do this with this piece of scrap here. But in order to drill a set of new holes, a power drill with a magnetic base would come in handy. So let's try to repair the Fein drill and mag base then. So this drill was made by Fein, a German company with a long history in power tool manufacturing. In fact, according to their website, they are the ones who invented the power drill back in 1895. A similar claim is made about the jigsaw, as is also quoted on the German Wikipedia page about Fein. And they are a company that seems to be quite proud about its history. And one thing that would indicate that to be true is the fact that they are willing to send you documentation of even their oldest tools, if they have something in their archive. So I sent them an email, asked about this machine, and they sent a reply. I learned that this is a Fein type ASQ55, which you can find in this catalog or leaflet here from the year 1936. They also sent me this technical drawing of the very similar model ASQ54F. So the first thing that I do is to clean the outside surfaces of this old timer. I do this by spraying the device with a degreaser and then working the surfaces with steel wool. The machine is almost entirely made from aluminium castings, which I really enjoy since I spent much of my time over the past 3 months to improve my skills in making castings from aluminium myself, a skill we will employ in this video as well, but more about that in a few minutes. After doing that, I proceeded by opening the handle that contains one of these really cool switches. We encountered a similar one just like that in another Repair-A-Thon some time ago. So there are 2 wires leading to the universal motor, and there's a third wire that connects directly to the metal enclosure. Modern power tools usually have fully insulated plastic enclosures and no connection to protective earth. The old all-metal enclosures obviously don't offer any insulation, but their enclosures are then usually connected to protective earth. Therefore, it's probably a good idea to only use these if your shop or house has a residual current device. So I proceeded to disassemble the drill. Machines of this type don't have a chuck. The drill bits have tapers, just like in professional machine tools, and you need a steel drift or wedge to get them out. You insert it into the slot and drive the drill bit out. This old drill bit has Ford punched into its side, and it's also a non-metric size. It's quite plausible that the Fein drill was once used in the Ford car factory in Cologne, Germany, founded in 1925. And after taking off the rest of the handle, I'm now checking the motor brushes. Older power tools usually have these screw caps on the side. They are there to make it easy to change the brushes. These ones are still perfectly fine though. And here's another lesson about electric motors. Traditionally, most stationary machines like the Georgi sander have induction motors, while handheld power tools usually have universal motors. And here is one easy way to tell them apart. If the motor has brushes, it's not an induction motor. It is a universal motor or a DC motor. And in terms of power tools that run on line voltage, it's then almost always going to be a universal motor. Unlike induction motors, they don't require a capacitor to run. If you still find a capacitor or a filter that might look like a capacitor inside a power tool with a universal motor, those capacitors usually serve the purpose of suppressing the noise generated by the motor. Their purpose is to protect radio equipment and other sensitive electronics. The motor doesn't need the filter to run properly, as this old machine proves. I'm usually only pulling the rotor out of the machine if it comes off easily. In most cases, it's not worth applying force to get it out, as you might damage the bearings without any need for it. In this case, we see some really old-fashioned ball bearings and can also have a look at the armature and commutator. But I don't see any obvious catastrophic damage, like burn marks or broken contacts on the commutator. As usual though, the grease inside the gearbox is very old, and that's why I'll replace it. In this case, baby wipes and some penetrating oil work pretty well in removing most of the old lubricant. Underneath all that gunk, we find very simple, straight-toothed reduction gears. It's probably not going to be the quietest power drill in the world. Whenever I apply new grease to any of these old machines, people ask me what kind of grease to use. Well, the answer is actually that it depends on how fast the gears spin. But as a simple solution, I would recommend you simply Google Makita gear grease. Why Makita? Well, because Makita sells these little tubes of gear grease that are supposed to be used in their power tools. That's it. They should be available internationally, and it doesn't require you to do any research in the world of lubricants. The stuff that I'm using here in this video is ball bearing grease that I just happen to have at hand. I actually bought another lubricant for this purpose, but simply couldn't find it. After also cleaning, testing and taking care of some of the smaller details, I put the machine back together and install a new power cable, and I also decided to wire wheel the surfaces. So does the machine work then? Well, it seems to work just fine. But in order to test it under load, let's first repair that Fein brand mag base as well. Before I started my work on that, I also prepared the old drill to get a fresh coat of paint. I decided to paint it orange like the Fein tools have been for many decades now. I'm not sure though the drill was orange back in the day, to be honest. Probably not. But I think it will look pretty good together with the base. So while that paint is drying, let's see if we can get that magnetic base working again. Another Fein device and another support email for this magnetic drill stand that also has the rather futuristic label Fein 2000. So from the leaflet of 1936, we are now catapulted into the distant future. The year is 1988. Man is now building bases on Mars, but also a wall around Manhattan to contain those gangs of post-apocalyptic cyberpunks that are now roaming the surface of the Earth. Outside those walls, just one elderly man and his Browning machine gun stand between those thugs and the good people of Earth. And amidst all that, some company in Germany still somehow manages to design this mag base as if nothing ever happened. What do you mean it's not a good idea to use YouTube as your sole source to learn about history? Be that as it may though, one of those post-apocalyptic scrapper gangs must have stripped the copper from this device. Mechanically speaking, it's actually not in terrible shape. It misses the most important part though. There is an iron core on the bottom, but the coil was removed, making this device quite useless. Fortunately, unlike what we're now used to, the operating instructions Fein sent me actually contain real technical details. This circuit diagram tells me that the line voltage is supposed to be rectified with an integrated bridge rectifier powering a coil made from magnet wire with 0.25 mm conductive cross-section area, resulting in nominal current of 0.35 amps. And since the maximum size of the coil is given by the dimensions of the iron core, we could now try to recreate a coil with that type of wire and fit as many turns into the given space as possible, and hope that the current will be roughly equal to that nominal value in the instructions. However, there are a few problems with that, and I will take another approach. I designed a coil former in a CAD program and printed it out with a 3D printer. And now I'm using ordinary 1.5 square millimeter insulated wire to fit as many turns onto the coil former as I can. The reasons why I don't follow the instructions from the manual are manifold. 0.25 millimeters is very thin magnet wire, and it will take a lot of time to hand wind that. I probably won't be able to wind the coil as precisely and densely as Fein did in their factory, and in the end I would end up with way less turns than they managed to do. When I then simply rectify the mains and connect that to my coil, that very thin wire will likely overheat, the insulation will melt, and all the work will be for nothing. And in the worst case, the face will be in direct contact with the metal housing as well. My thick wire here will yield way less turns, but with a much bigger cross-section. Connecting a small power supply, for example 5 volts 10 amps, should create a very powerful magnetic field as well, spending way less time winding and being less dangerous. This is how I did it before and it worked. At least for our test here, that will be good enough, I think. So I have now connected the coil to an adjustable lab power supply to test it. In the meantime, I also tried fitting the drill into the stand, and I managed to do that with the help of a 3D printed reduction piece that I will later recreate on the lathe. While both drill and stand do now work in principle, let's try to put in a little more work into maintaining the magnetic stand for the future. The handles can simply be unscrewed, and after removing a safety ring, the axle, with the gear that is part of a rack and pinion mechanism, can be pulled out as well. Because of years of use and abuse, it's quite dirty, of course. The same goes for the rack and basically everything else. So I took care of that with a lot of manual brushing and cleaning with wire brushes, wipes and different cleaners until the parts look much better. I also removed the remaining electrical components, at least temporarily, to prepare the enclosure to be painted in that same orange color we used for the drill. And after waiting for a while, we were ready to both unwrap the stand and the drill, shining in a new bright orange coat of paint. So the time had come for a real-life test then. The Georgi Cobalt sander needs a base plate, and that's why I had started to wire wheel this piece of scrap here. We will now use the mag-based drill to drill a number of holes to fit that sander. And in the end, these old machines got the job done, which is not bad considering that we found that drill in a catalog from 90 years ago. And there was actually another object in that same container that has a certain historic significance. So this is a kind of gear pump that I also found in that same container that I took the Fein drill from. Since this video focuses on power tools, I'm not going to work on this pump today, but I wanted to show you something quite unusual. The overall style of this motor reveals that it is very old, and after cleaning it up we can read the nameplate saying Elektrobudowa, which sounds very Slavic rather than Germanic, and then it says Elektromaschinenbaufabrik Litzmannstadt, which is just a very long German word meaning electric machine factory in the city of Litzmannstadt. And in case you live in Germany, Austria, Switzerland or neighboring countries but have never heard the name of that city, that's because Litzmannstadt as a name only officially existed for 6 years or so. It was the name that the German government used from 1939 to 1945 for the Polish city of, well, we call it Lodz, I think it's more like Łódź, while it was under German occupation. And as far as I know, that name was not used before or after World War II. I have never seen that on any nameplate, and it is also of a certain personal significance to my family's own history. See, my family on the paternal side were Germans that had moved from Germany to Lodz in the middle of Poland more than 200 years ago. As far as I know, all of them had to leave Poland after World War II though. Actually, I'm quite the mix. My maternal grandparents are a mix of Denmark and the Baltic coast of northeast Germany, while the paternal side is a mixture of Lower Saxony and German migrants that had lived in Poland for 200 years before the end of World War II. I've actually not met that many people in my life where all 4 grandparents came from different parts of Europe, but I'm sure many of the American and also Australian viewers can relate. Anyway, I'm sure we will encounter this pump again. But for now, I want to continue the tool restorations. The next scrapyard find is a wall chaser. It's basically like a special type of saw, if you will, that is typically used by electricians to cut narrow grooves in walls to install cables inside. Judging by its general appearance, I would say this device was made in the 1960s or 70s by METABO. And this actually takes us all the way back to the very first episode of this series. I started doing these Scrapyard Repair-A-Thons back in 2019. Before that, I had already been very active on YouTube since 2014, but the Repair-A-Thons brought a whole new audience to this channel. I have since made more than 40 episodes, and you can find those episodes in the video description. And it was actually the very first object in the very first episode that was a METABO hammer drill from the early 1970s. And I'm still using that drill regularly here in the shop. The name METABO is derived from an old-fashioned German word for power drills that is no longer in use. However, even if you don't speak German, it's kind of easy to understand. Meta like metal, bo like bohren or boring. By the way, Fein, Georgi, METABO, they all come from the southeast of Germany. While we have seen that a lot of the forged hand tools that I have presented in earlier episodes were from a specific region in Western Germany, another big cluster, in this case of automotive manufacturing, mechanical engineering and so on, can be found around Stuttgart and the wider southwest of Germany. And that's where these companies are all from. But be that as it may, 6 years later we have finally found more METABO devices, and this one is super dirty, but I think yet another diamond in the rough. On the outside we find this disgusting amalgamation of dust and grime that somehow has incredible adhesive forces. People spent decades coming up with the best possible adhesive in chemical labs when it was there all along. Strong solvents like paint thinner and gasoline/petrol can help you to get that stuff off. But they also dissolve the actual paint, which is not what you want, and it's also not very healthy to work with that kind of stuff all the time. The reason why there is so much space inside the guard, and also why there are so many spacers, is because you can install more than one cutting disc here. After detaching all those parts and scraping off some of the thicker dirt, they are put in warm water with detergent, before some of the parts will be suspended in citric acid. Meanwhile, we can start to work on the insides of this machine. And again, we have another device almost entirely made from beautiful aluminum castings, except the electrical components are actually housed inside these plastic inlays for insulation purposes. And we can apply the rule from before once again. It's a handheld power tool, it has motor brushes directly powered by AC, it's a universal motor, doesn't require a capacitor. The brushes are still okay by the way, but covered in this nasty dust that we find everywhere inside the enclosure. We will get rid of that, but it's normal when your job is to cut grooves into walls. After managing to open the gearbox, we find really old lubricant yet again. But this time the gears are not straight spur gears, but somewhat more advanced helical gears. I also want to stress that this is all very massively designed and that these axles have their own roller bearings instead of simple bushings or just drill holes. New grease is applied and the treatment is basically the same as with the Fein power drill earlier in the video. Eventually everything is put back together and a new cable is installed. The nameplate says Schutz-isoliert, referring to the plastic insulation. Hence, there is no protective earth connection here. And since I don't have slightly greenish silver hammerite style paint, I decided to only apply a neutral gray foundation to that guard. And the chaser works just fine. As I had shown in the beginning of the video, I also found this METABO bench grinder and REMA polishing machine. I've already repaired both devices and filmed everything. However, the process was quite a lot of work and it even required me to cast aluminum replacement parts, and I simply can't fit all that content into just one episode. That's why the entire repair process will be shown in the next Repair-A-Thon episode that I'm already working on. However, let's at least start to work on the bench grinder so you know what we are dealing with here. This METABO bench grinder certainly has seen better days, but I think there's a lot of substance and hidden beauty here. Unlike more modern grinders, it's not made from bent steel sheets or even plastic as we now see in a new race to the bottom, but instead was made from iron castings, heavy yet still made with precision, and beneath the rust I think with an eye for aesthetics. The power cable was cut off at the scrapyard, but after removing the bottom plate we can see that that cable is actually brand new, but there is again no capacitor inside. Let's check again. Stationary machine, no motor brushes. It's an induction motor. And to run an induction motor on single phase alternating current you need a capacitor. There are rare exceptions, like the shaded pole induction motor, which is used in things like the fans inside microwave ovens. But due to its very low efficiency, that type of motor generates a lot of heat and is thus not suited for high power applications like this. More about that later, but I suspect that this is yet another device that was thrown away because whoever owned it last didn't know how to get it to start and run. In the meantime, I have measured the resistance of the motor connections and I believe that the motor is still in good condition. So I started to disassemble the machine completely, to check the condition of the machine from the inside and also to remove all the rust and old paint and so on. Unfortunately, the outer guards protecting the grinding discs, or rather your hands, are missing, and I will have to make new ones for this grinder, which will be a lot of work. After taking everything apart, you can now see all the parts of the bench grinder laying before you. And I did this before actually putting them into an acid bath, or most of them at least. I think it's always fun to see all the parts in one place, and I'm sure many of the viewers agree. See, my main interest with these videos is not to repair these specific devices. It is that I want you guys to learn something from these videos. With that in mind, many of the parts are now in that acid bath, waiting for the next step. And that is where I will make the cut today. The rest of the process will be shown in the next Repair-A-Thon. So, that is all I had for you guys today. And in case you liked the video, please give it a like. It would mean a lot to me. If you can, consider making a donation to support the production of future videos, or become a supporter on Patreon under patreon.com/tpai. Links for both are under the video in the video description. See you soon.